In this video, I would like to give a short introduction to the PANDA reverse engineering tool. And PANDA is an open source tool, and PANDA is short for Platform for Architecture Neutral Dynamic Analysis. So it's a tool that is built on top of the qcow system emulator, and so according to the website, and so all analysis have access to all code executing in the guest, and as well as all data. And PANDA has the ability to record and replay executions. And this is really one of the cool concepts that you will see from PANDA, meaning that you can emulate an operating system, you can execute this in however way you like, and then afterwards you can replay that execution, which then enables you to do iterative, deep, and whole system analyses. So you can do sort of like a quick execution by way of qemu or PANDA's version of qemu, and then you can start to deploy various many different types of analyses, some of them extremely strong, such as, for example, information flow analysis. You can start to do that on your recording of the executing system. And this is a really powerful technique and tool for reverse engineering. So what I want to do in this video is just simply go through a first view into PANDA. And the reason I'm also doing this video now is they have just gotten this new website. It is a fairly active project, and I also really like this project a lot because I did some academic work for a few years where a lot of the tooling that I wrote was essentially based on PANDA, and I used that to do various malware analysis related attacks. So if you're interested in that, you can also search for this title and you should be able to find the research work I did. Okay, so what we're going to do is we are going to install PANDA, we are going to compile it from source, and then we're going to try and run it. And you can see here, PANDA has a nice GitHub repository where it has all of the source code available, and we can see here that there is the qemu source code, and we have the PANDA source code inside of this subfolder PANDA, where you will find all sorts of things related to PANDA, such as the various plugins, some of the sort of like core source code, and a bunch of other related things, such as a Python interface to PANDA, and more on that. And just to go a little bit more into what PANDA can actually offer, it can do various things, such as it provides a lot of convenient callbacks, which make it very convenient when you are writing analysis tools. It also has this taint engine, which makes it very convenient to do information flow analysis. And then it also comes with a lot of operating system introspection, which essentially allows you to extract high-level data about the extract high-level data about the system that was executed. So, for example, you can see things like which processes happened executed within the operating system, what modules within each of these processes, and so on. It also has this modular plugin architecture, which makes it very nice to do sort of like to reuse a code that has been written to PANDA and incrementally build up very complex analysis tools. Okay, so the way I will approach this is that I wrote a blog post I think almost 2 years ago or something now, on how to essentially get started with PANDA, and with the purpose of creating a simple malware sandbox. And I'm going to follow a little bit of the structure of this blog post, because it has some convenient commands in order to install and run PANDA. And although a few things have changed, so we need to adapt just a tiny bit. Okay, so the first thing we have to do is simply just clone it. So we will do that over here, just to verify. There's nothing so far. So we'll simply just clone it now. And then the next thing we really just have to do is we have to install it. So we have to install PANDA, and it has a very convenient script called install Ubuntu that will do most of the work for you. And we can see that that tool exists within here, scripts, and it has install Ubuntu. And we can also see that it actually has installation scripts for various other architectures, which is fairly convenient if you are on a different operating system. Okay, so this will just take a little while, and I will resume the video once it has cloned all the way. Okay, so we cloned the repository now, and we have it here. And now we can simply just execute this command called install Ubuntu, and that should be good enough to have our PANDA installation complete. So this is also going to take a while because it's going to compile the entire of the QEMU source code as well as the PANDA source code. And yeah, this just takes quite a bit of time. So you can see that there's a lot of stuff here. So I'm going to pause the video and then resume once this is over. Okay, so we now got we now compiled PANDA, and we are ready to look at the executables provided and also try and run it. So if we go into PANDA and we go into build, here we will see the build files produced by PANDA. And we can also go into the various, we can look at the various front ends that PANDA created, and we have here the PANDA system i386, and this will be our substitute for qEMU i386. Okay, now what we're going to do now is we're going to take a Windows image, and we are going to run that Windows image with the PANDA emulator, and then we are going to do a recording of our execution, and then we're going to replay that execution afterwards. In order to get this image of Windows, I am going to use these developer provided Windows images by Microsoft, and in particular they have this website where you can get various virtual machines with Windows in order to test, essentially test the applications that you're developing. And you can do things such as get Internet Explorer 8 on Windows 7, 9 on Windows 7, and so on. And I have already done that. So I have this installation script here, install_image, where essentially the only thing we do is we create a working directory, we change our directory into there, and then here you have this vget command that will download one of these VirtualBox images from this website. But I've already downloaded it, so I will just copy it. And then we are simply going to unzip this folder. We're going to extract the OVA file, and then we're going to install something called qEMU utils. And we're going to do that because we need this qEMU image, because we need to convert this OVA image into a qcow2 format. And that's essentially what this script will do. It will just prepare a qcow image for us, such that we can run it in qEMU. Okay, so I will just run this script. And this is also going to take a while, so I will resume once this has completed. Okay, so this finished now, and we now have this working directory where we have inside a qcow image here that we can use to run PANDA in. So, okay. So what we're going to do now is we're going to use this small command here, this small script I have, in order to run PANDA. And let's just take a look at how it is composed. So we have these, we simply call into the PANDA system i386 that I described previously, and we just need to go up on the directory. And we then say we want to have, we want to show cursor, and we have this monitor for standard in, which means that we will be allowed to type in commands while qEMU is running. And then we also give a path here to our qcow image. And in this case, we need to put in workdir else follows. And then we also say we want to allocate 8 gigs of RAM to the emulator. Okay, so what we're going to do now is simply run this, and it should work from the get-go. It did not, and that is because I got the name wrong of this one, I assume. Run PANDA. Okay, as follows. Okay, so now PANDA should start to boot Windows, and that's exactly what it does. And you can see that we have a qEMU command line here, and that looks fine. And we have various PANDA commands here, such as if we go a little bit up, we can see begin replay, and this is related to well, essentially this command will start to collect all of this non-deterministic input to the CPU and essentially start a replaying session. And then we have one called end replay, and this will then be the command that will stop a given replay session. And naturally, we're actually interested in end record and begin record rather than replay. So here we have the begin recording. So where is that begin replay? Begin record here. Exactly. So this is the command that will launch a recording session in Panda, and then we have the end record, which will end the recording session. And I'm going to fire up these commands once Windows has booted, and then we will take it from there. Okay, so we now have Windows booted, and we can see that we can use the system in a regular manner. Everything seems to be working fine. And what I'm going to do now is I'm going to exit qemu here, and then I'm going to type begin record. And once we do that, I'm going to go into the QEMU instance again, and I'm going to start the calculator application. And once the calculator application has started, I'm going to end the recording. So let's try this. And begin record, help begin record. Begin record as follows. Why is this not working? Maybe as follows, begin record sample. Okay. And now we are creating this sample file that will contain all of the data for the recording, but I'm going to go through that in just a while. And now we launch the calculator. And once the calculator has popped up, I'm going to end the recording. And it should not take too long before the calculator pops up. And there it did, it popped up. So let's exit QEMU and say end record. And it took a total of 28 seconds to do this recording. And once we see a checksum here, we are good to go. And I will simply exit QEMU here. Let's say, how is it that you exit here? As follows. Okay, so now we have these two files, sample and sample RR non-deterministic log, and then we have the snapshot at the beginning of a snapshot that was taken at the beginning of the recording. So the whole point is here that this will contain the snapshot at the beginning of the recording, and then this log will contain all of this non-deterministic data to the CPU that will then be during a replay session will then be passed into the CPU, and that is essentially what achieves this whole record and replay structure. Okay, so what I will do now is I would like to replay this recording. And to do that, we will use this simple, it's super simple to actually do the replay. We can simply do as follows, take this command and simply copy it in, and we just need to go one up. And here we want to give the same commands as we did when we did the recording in terms of how much memory we want to allocate to the QEMU instance. But we will get this replay command line argument, and that will tell Panda to perform a replay rather than launching QEMU as usual. And we're then going to say we want to replay sample, and sample here corresponds to the name that we gave our recording once we typed this begin record. So we gave this sample here, and thus it will grab these sample files. So let's just try and replay it and see what happens. And we can see that now it begins to replay. It tells us how far in the replay it has come, how many instructions are running, how much memory it takes up, and the time it has taken to do the replay, and so on. And right now we are doing no analysis at all. But you can imagine that because we are replaying all the instructions, we could do a ton of analysis, and that is the analysis that Panda is really aimed to help do in a sense. So it makes it easy to write these analysis tools, and we can now do analysis of all sorts on the replayed instructions. So say, for example, if instead of launching calculator, we launched a piece of malware, we could now analyze the behavior of the malware on a very sort of fine-grained level because we have access to everything within the system. Okay, So I'm just going to let this replay through and just to see a full replay run. So Panda now completed the replay, and we can see that it replayed all of the instructions. It took 72 seconds, and I think the recording was 28 seconds. So in that case, it was, well, let's say 2.5 for good sake. And there's a bunch of input here. There's a bunch of data about the replaying. Okay, so now I would like to show a little bit of the powers of Panda in a sense. And this is just a very, very little glimpse into it. And the way I'm going to do that is I'm going to leverage some of the existing plugins for Panda. And namely, I'm going to leverage the plugins that does operating system introspection. So we are going to have a bunch of logging in terms of all the names of all the processes that are running on the system and things like that. And if you're interested in looking at more on how this plugin works, you can go into plugins, and then you can look at plugins such as these introspection plugins right here. So Win7 x86 intro, and you can look at plugins such as OSI and OSI test here, and also the plugin called Wintrospection right here. Okay, and the way we're going to do that is we're going to just launch a simple command here that does the exact same as we just did, and then also gives some launches some plugins, which we do by giving this Panda command line argument. So we are saying that we want to launch the OSI plugin, and to that plugin we give a argument. So to the plugin OSI, which is this one, we give an argument that says we are going to introspect. So this is operating system introspection, and we say that we want to introspect a Windows 32-bit, Windows operating system, 32-bit, and Windows 7. And then we also want to use another plugin, which is the Win7 x86 intro, and then also finally OSI test. And this OSI test plugin is the one that will give us a bunch of printouts in terms of that's the one that will do all of the logging for us. So let's just, and again, we simply just give the sample here a name of our replay. Okay, so let's just try and run this and see what happens. So a lot of stuff is happening now. We can see a bunch of logging, and I just terminated it now, and we can see, for example, it says current process is this one, and we have the whole process list of the operating system. We have a bunch of common ones here: Explorer, exe, SVC host, and a lot of other processes. And we also have some dynamic libraries, and I think these are the dynamic libraries loaded by the current process. So if you remember, the current process was driver drv-inst.exe, if I remember correctly. This one, yeah. And we then have all of the modules loaded in this user space, in this process, and these are just well-known Windows modules. We also have some kernel. We can also list the kernel modules that are listed. We also get a list of the kernel modules on the system, and just a bunch of introspection about the operating system. And this is just an example of what Panda can do, and you can naturally do. This is quite a coarse-grained analysis of Panda, because you can also go down to sort of like instruction level analysis and do very fine-grained analysis. Okay, so what I'm going to do is I'm going to run this replay, and I'm going to output all of the logging, let's say to log1.txt. And the purpose is now to, after this has replayed, look at the log and see if the calculator process is ever started, and if so, also see when it actually did. So I'm simply going to replay this, run this command, and then I will resume the video once this has completed. So the replay now finished, and we can see that we got a little bit of error output, but besides that, all seems to be going well. And let's try it now and look at what is in log1.txt. So let's first just verify what is in log.txt, and we can just see a bunch of logging really. And we can also see that it took 91 seconds to do the replay. So in fact, it wasn't it wasn't that heavy in terms of the original replay without any plugins was 72 seconds, and this one is now 91. Okay, so what we want to do now is we want to, first and foremost, let's see if we can actually see where the calculator is, what was running in the system. And if we do that, we see nothing. And okay, we see that now, and we can see a bunch of printouts for calc.exe. And if we try to read this file and search for calc, that was the wrong word, as follows, then we can see that around 24% inside into the log, we get this first instance of calc.exe inside of the processes running. And this makes a lot of sense, since it did take me a little while before I could actually get calc.exe onto, so like it took me a little while to actually start the process. Okay, so this was essentially what I wanted to show in the video. Just a very brief introduction to Panda, where you can see all sorts of things. And we went through how to build it, how to install it, how to get a Windows image that we could use for analysis, and then also doing the most simple form of record and replay in Panda. And the next step now is really to get a bit more comfortable with some more advanced features and some more kind of like practical use cases in terms of how do you execute your own binaries, how do you develop interesting plugins that can do sanitizers, that can do some type of malware analysis, and all sorts of reverse engineering related tasks. Okay, so that's it for this video. I hope you enjoyed it, and I hope you will try out Panda. Thanks for now.